Well, now the next big topic is configuring Spack. So we now know how to use it, but now let's go to the next part, how to configure Spack. And Spack has several scopes for configs. Default scope with factory settings, system scope with settings for the concrete machine, side scopes with setting for the concrete Spack instance, then user scopes with some which are taken from the home directory of the user. And you can also use some custom folder with some configuration files to as a config source. And basically, when Spack concretizes some configs, it uses them in the following order. The most prioritized is custom scopes, and the least prioritized is default scopes. So if you will take a look on the content of the config files, config scopes, let's say, you will have you will see a list of YAML files, and here is what kind of files you can basically find there. You can find all these files, let's say, and I will go quickly through all of them right now. So the first, but before I will go through them, I need to tell you how to edit these config files and how to take a look on the content of config files and how to convert some deprecated config files to the current current version of Spack. And basically all that stuff can be, you see commands used for all that stuff on this slide. So now let's go to the more interesting part, is which is configs themselves. So the first bunch of things which can be configured is defined in config YAML. And in this YAML file, you define some high-level configurations, something high level, such some such information like the list of directories used for installation of the package, for staging, for testing, for caching, the list of different general purpose options. For example, here I define that when I build something with make, I should use option G32 and so on. So the next configuration YAML script is packages YAML, and in this file you define permissions for the installed packages. For example, here I tell that for all packages, we'll make them readable for everyone and writable only for people who belongs to the group Spack. And for this concrete package, UAP simulator, we will make it readable for the group HID UAP. Then we can also, like in environments, we can also define here, and we should, concretization preferences. And here is an example how to do it. So here I define preferences for Python. Here I define preferences for all packages, and in particular here I define that we should prefer a GCC at the first, GCC 10.2 at the first place. Then we can use Clang. If we cannot compile it with GCC, then we can use to another version, switch to another version of GCC or Intel. Here I tell that our target microarchitecture is Zine2, which is actually the microarchitecture of the Hawk, behind the Hawk nodes. And here I tell the preferences for the providers of the virtual packages. For For example, on the Hulk, we should prefer NPE version of MPI. And as a second priority, we can take OpenMPI. So next, external packages. Well, besides these concretization preferences and permissions, you can also register in the packages YAML. You can also register external packages, and in order to do it, you should just use package name, then externals, and then define the spec which you want to assign to that particular external package, and how to use this external. It can be used. It can be where from take this external. It can be taken from a module file, and in this case you can use modulus, or it can be taken for some particular prefix for some particular folder, and in this case you use prefix. And you can also tell whether this package can be buildable or not, which means, for example, if I define here MPT buildable false, which it means that if I will try to install MPT with some different versions, Spack won't be able to do it. It will always take this particular installation of Spack and of MPT. And in the case of MPI, OpenMPI, I do not define buildable false, which means that buildable will be true by default. And it means basically that OpenMPI can be installed by the users after all. And these external packages, OpenMPI 4.0.5 and 4.0.4 compiled with GCC, they will be used only if during the concretization you will select this concrete spec. So, but generally we usually don't want to be MPI buildable at all on the clusters by external users, and in order to tell them to tell Spack not to do it, you can define also buildable false for virtual packages, not only for the real packages. So the filling of packages YAML, these external packages, is a time-consuming process, let's say. And in order to simplify it, you can use Spack external find command. And this command allows you to find many external packages, but well, let's say it is defined only for build-only dependencies, for common build-only dependencies such as CMake, pinutils, I don't know, Python, for example, and so on. So for those files which are used in the build part, but not for linking or for running. And yeah, so in order to be visible for Spack external find, this package should be made with some additional tweaks, and visible packages are called discoverable packages. And if you want to know more how to make discoverable packages, you can follow this link. Yeah, you can list all discoverable, all packages which can be found by external. And here is the list which is available on my version of Spack. So next part is how to define compilers. Compilers are defined in compilers YAML, and the simple definition of compiler can be like this. And as you see, you define compilers for paths to, here you define paths to C, C++, Fortran compilers. You can also specify operating system, target, well, target, in this case, you do not have much flexibility with target. So you cannot, in compiler section, you can't define Zine2. You should just define like a family of compilers. And in this case, it's, in case of Zine2, for example, it's x86, 84. You can also define modules if you don't want to specify prefixes completely. So in this case, let's say in this example, this opt HLRS and so on, it was not necessary. You could simply write AOCC clang if you use modules AOCC to 0. You can define other stuff like environments and so on. And yeah, important stuff. For each compiler, you should also define a spec which will be used for this compiler. So let's say the nickname of the compiler which will be used in the installation process when you define some specs, some user-defined specs. So, and basically here you have an opportunity even mix different compilers. And here is an example how to do it. For example, here I use Clang for C and C++, and use gfortran from user bin for Fortran compilation. And also you can define flags by default. So like, for example, to tell Spack always compile everything with this concrete Clang gfortran C80 spec, always compile everything with options O3 and fpeak. So next part, next question is, again, filling up compilers YAML is somewhat time consuming. You can automate, make it more automatic. And for doing this, you have command Spack compiler find. For example, here you can module load GCC, you can load module GCC and use compiler find GCC to register GCC compiler from this module. And yeah, if you want to register something in some, by default, compiler, if you use this Spack compiler find or Spack external find, it will always register the stuff in the home folder of the user. So, but sometimes it's not something that you want. For example, if you have the system which shares, well, you have two clusters which share the same shared folders, for example, Vulkan and Hawk in case of HLRS, then you will face the problem. You should somehow decouple compilers for Vulkan and for Hawk. And in order to do it, you can always tell Spack that you want to use some user-defined scope, and it will use this concrete scope instead of home folder to register packages and compilers. So here is another example. Well, basically, you can even install some compiler with Spack. For example, here I install Clang8 with Spack and register this installed compiler. And yeah, you have already all the knowledge how to do it. You just install, well, here I made a small mistake. You have to load. No, you don't have to load because, well, we have an instruction Spack location, which will tell the concrete path to that Clang, and yeah, it will register Clang. So next part, mirrors. Mirrors are basically some repositories of the source tuples, let's say. And by default, we have one specific mirror, this mirror, from where Spack takes all the packages, but you can define your own mirror. You can remove this one and define your own mirror, and you can even define offline mirrors, which will be handy afterwards. in our discussion. So and here is the way how to define offline mirror. So repositories. Repositories, we already talked. Repositories are just a set of Python-Py scripts for all the packages. And Spack provides a default repository called repos built-in, but you can add new repository, add your own repository, or remove this built-in repository if you don't need it, and so on. So upstreams, Spack also, we already talked that Spack installed packages come with some metadata folder. So it allows Spack to reuse already available installations of other packages if they were installed with Spack. And this option is called upstreaming. And basically, if you want to upstream some already installed packages, some other packages which were already installed with Spack, you have to basically define upstream's YAML file where you specify some name of this upstream, which can be actually anything, almost anything. And then you put install tree, the reference to the installation tree of the external Spack. And yeah, this install tree parameter should contain basically the path to the external tree. Next part, important stuff to know, in my view, is that, basically it makes not much sense to put configs hidden. And basically Spack community tries to encourage people to share their knowledge on how to configure systems and so on. And such sites like such organization like ORNL and LLNL and so on, many others famous HPC, like let's say organization, they share scripts how they configure their clusters with the Spack. And it would be also nice if you configure your clusters and share this experience with other people too.